$1.8 trillion. That is the projected lifetime cost of the F-35 fighter program, the most expensive weapons system ever built. And that number is not even the part of the story that should make defense planners uncomfortable. Because at the same moment, the United States is investing roughly $1.8 trillion into a single aircraft ecosystem, a far cheaper Swedish fighter called the Gripen continues appearing in international exercises with performance results that complicate the simple narrative of technological dominance. The F-35 was designed as a fifth-generation stealth aircraft built around sensor fusion, data networking, and deep strike capability against advanced air defenses. It is an extraordinary machine on paper and in many operational scenarios. But there is a separate question that defense analysts quietly debate behind closed doors. What happens when the most advanced aircraft in the world also becomes the most expensive aircraft in the world to operate? Picture a stretch of highway in northern Sweden. Snow piled on the shoulders. Cold air hanging over a narrow strip of asphalt. A fighter jet rolling to a stop beside a refueling truck and a small team of mechanics working in heavy winter jackets. That image is not theoretical doctrine written in a defense white paper. Sweden has practiced highway-based aircraft dispersal for decades through a system designed during the Cold War called BA-90, which allows fighters to operate from temporary road runways instead of centralized air bases. The idea was simple and brutally practical. If an enemy launches a surprise strike against fixed airfields, the aircraft survive because they are already scattered across the country. That small design philosophy becomes important later in this story. Because while the F-35 program expanded across NATO with partners including the United Kingdom, Italy, the Netherlands, Norway, and others, a parallel debate quietly grew inside defense ministries about cost, readiness rates, and long-term operational flexibility. According to widely reported Pentagon data, the F-35 program's total lifetime cost projection sits around $1.7 to $1.8 trillion when development, procurement, and decades of maintenance are combined. That number became the anchor for every subsequent discussion about the aircraft. Every new cost estimate, every readiness report, every procurement decision ends up measured against that enormous financial baseline. And those readiness reports introduce the first cracks in the conversation. Official U.S. Government Accountability Office reviews and Department of Defense reports have repeatedly highlighted challenges with maintenance complexity and availability rates across the F-35 fleet. Readiness numbers have improved in recent years, but the aircraft still requires extensive logistical infrastructure, specialized maintenance facilities, and highly trained technicians. None of those characteristics are unusual for a cutting-edge stealth fighter. Advanced aircraft are complex machines by design, but complexity changes the economics of how often those aircraft actually fly. That is where the comparison debate begins. Because another fighter jet built in Sweden followed a completely different philosophy from the start. The Saab JAS-39 Gripen was designed around affordability, rapid turnaround times, and the ability to operate from dispersed locations with minimal logistical support. Instead of focusing primarily on stealth, the design emphasized electronic warfare capability, data networking, and operational flexibility. The goal was not to outspend larger air forces. The goal was to stay airborne longer with smaller budgets. That difference in philosophy produces two very different cost profiles. Publicly reported estimates place the F-35 cost per flight hour somewhere between roughly $33,000 and $41,000, depending on the model and accounting method. Estimates for the Gripen's operating cost are dramatically lower, often cited between approximately $7,000 and $10,000 per flight hour. Exact figures vary depending on fuel, maintenance accounting, and mission configuration. But even conservative comparisons show a large gap in operating cost. Over decades of fleet service, that difference compounds into billions of dollars. And that is where the strategic conversation becomes more complicated. Because air power is not just about how advanced an aircraft is. It is also about how often pilots train, how frequently aircraft deploy, and how resilient an air force remains under stress. An aircraft that costs less to operate can theoretically fly more hours for the same budget. More flight hours mean more pilot training and more readiness across the force. The most sophisticated fighter in the world loses value if large portions of the fleet remain grounded due to cost or maintenance. That tension is not hypothetical. Across Europe and North America, governments have spent the past decade making difficult procurement decisions about fighter aircraft as older fleets age out of service. Canada launched a long competition to replace its CF-18 Hornet fleet. Finland evaluated multiple aircraft before selecting the F-35 in 2021. Switzerland chose the F-35 as well after a controversial competition that included the Gripen in earlier phases. Each of these decisions triggered intense debate among military planners, economists, and political leaders, because each decision carried consequences far beyond a single airplane purchase. The aircraft a country chooses often determines its training pipeline, its weapons integration, its maintenance ecosystem, and its strategic partnerships for the next 40 years. Buying American aircraft deepens integration with U.S. logistics networks and intelligence sharing systems. Buying European platforms can diversify supply chains and increase domestic industrial participation. The choice is never just about performance statistics on a technical chart. And during those debates, one recurring argument continued surfacing. Is it better to operate a smaller number of extremely advanced aircraft or a larger number of more affordable fighters that can remain airborne more frequently? Defense ministries rarely answer that question publicly in simple terms. But internal discussions repeatedly circle back to readiness rates, sortie generation, and operational resilience. The more expensive an aircraft becomes to maintain and fly, the more pressure it places on training budgets and long-term sustainment plans. That is where the exercise data begins appearing in the conversation. International training exercises like Red Flag in Alaska or NATO air combat drills exist for a specific purpose. Pilots simulate combat against Allied aircraft to test tactics, sensors, and pilot skill under realistic conditions. Results from these exercises rarely translate directly into real combat outcomes. Variables like radar visibility, weapons loadouts, and mission rules are carefully controlled for safety and training value. But they still produce insights that military planners pay close attention to, and sometimes those insights surprise people. In several multinational exercises over the past 2 decades, the Swedish Gripen has demonstrated strong performance against various fourth-generation aircraft platforms when flown by experienced crews using modern missiles and data links. Analysts often emphasize that these outcomes reflect training scenarios rather than real combat, but they still highlight an important point. Advanced avionics, modern sensors, and effective pilot tactics can allow smaller aircraft to compete effectively against more expensive fighters in certain scenarios. And that observation opens the door to a much larger strategic debate. Because air power in the 21st century is evolving rapidly as new technologies appear. Long-range air-to-air missiles, advanced electronic warfare systems, and networked battlefield data links change how engagements unfold. Meanwhile, unmanned drones, artificial intelligence targeting systems, and distributed sensor networks are beginning to reshape how air combat might work in the future. The result is an uncomfortable question inside defense circles. What matters more in the next conflict, the most advanced aircraft ever built, or the ability to keep large numbers of aircraft flying consistently across long campaigns? That debate is still unfolding. And one quiet detail inside this story makes the entire situation even more complicated. The engine inside the newest Gripen model is built in the United States. That detail seems minor at first. Later in the story, it becomes the hinge that could decide everything. That engine detail changes the entire geopolitical calculation. Because the newest version of the Swedish fighter, the Gripen E, uses the General Electric F414 engine, a power plant manufactured in the United States. Exporting that engine requires approval under U.S. export control rules, meaning Washington ultimately holds legal authority over where that aircraft can be sold. That small technical detail quietly places American leverage inside a European fighter program that was originally designed to give smaller countries strategic independence. For most of the past decade, this arrangement attracted little public attention. But once multiple Allied countries began evaluating alternatives to the F 35, that quiet dependency suddenly became strategically significant. Read that again. A fighter designed to help nations maintain independence from large military powers still relies on a critical component manufactured by one of those powers. Defense procurement experts immediately understand the implication. Aircraft programs are not just engineering projects. They are supply chains stretching across borders, industries, and governments. And supply chains create leverage. If one component in a system depends on another country's export license, the aircraft itself can become entangled in geopolitical negotiations. That reality sits directly beneath the current debate over fighter procurement among several Western allies. Take Canada's long-running fighter replacement program as an example. For more than a decade, Ottawa evaluated options to replace its aging fleet of CF-18 Hornets, which first entered service in the early 1980s. Several aircraft were considered at different stages of the competition, including the F-35, the Boeing F/A-18 Super Hornet, the Dassault Rafale, the Eurofighter Typhoon, and earlier variants of the Gripen. Each aircraft came with different industrial promises, operational characteristics, and alliance implications. The final decision carried enormous consequences because the chosen aircraft will shape Canada's Air Force structure for the next generation. And that decision eventually moved in a very specific direction. In January 2023, the Canadian government officially announced plans to purchase 88 F-35A fighters from the United States, replacing the entire CF-18 fleet. The program is expected to cost tens of billions of dollars across procurement and sustainment over several decades. The decision aligned Canada more deeply with several NATO allies already operating the aircraft, strengthening interoperability and shared training pipelines. It also reinforced the growing global network surrounding the F-35 program, which now includes more than a dozen partner nations. But that outcome did not end the debate. Because even as many Western air forces moved toward the F-35, analysts continued raising questions about long-term operating costs and fleet readiness. According to widely reported Department of Defense data, the F-35 program still faces ongoing efforts to reduce sustainment costs while improving availability rates. Pentagon officials have publicly stated goals of lowering the cost per flight hour over time. Progress has occurred, but the numbers remain under constant scrutiny due to the sheer scale of the program. And that scrutiny feeds directly into a larger strategic concern. Air forces do not simply buy aircraft. They buy decades of maintenance contracts, software upgrades, spare parts pipelines, pilot training systems, and weapons integration. Once a country commits to a fighter platform, shifting away later becomes extremely difficult. Defense budgets are finite. Every dollar spent maintaining aircraft infrastructure is a dollar not available for other capabilities such as drones, missile defense, cyber warfare, or naval power. This is where the second layer of the debate emerges. Many analysts believe the real question is no longer which aircraft is best, but rather what combination of systems provides the most resilient air power. Fifth-generation stealth fighters like the F-35 excel at penetrating advanced air defenses and sharing battlefield data across networks. But less expensive aircraft can perform air policing missions, homeland defense patrols, and training sorties at lower cost. Some defense planners quietly argue that balanced fleets may prove more sustainable than single-platform dominance. The next data release on readiness rates will arrive soon. Based on everything covered here, what do you think it shows? Because readiness statistics reveal something many public discussions overlook. Air power depends on how many aircraft are actually available at any given moment. A nation could theoretically own hundreds of advanced jets, but if a large percentage are grounded for maintenance at any given time, operational capacity shrinks quickly. This is not unique to the F-35 program. Every modern fighter faces maintenance cycles. But the complexity of stealth coatings, advanced electronics, and sensor systems increases logistical demands significantly. And that brings the story back to the design philosophy difference. The Gripen's creators prioritized rapid turnaround times between missions. Swedish military doctrine historically assumed the country might face a sudden attack on fixed bases. Aircraft, therefore, needed the ability to land on temporary roadways, refuel quickly, rearm quickly, and return to the air with minimal support equipment. This approach sacrifices some stealth advantages, but dramatically increases operational flexibility in dispersed environments. Picture this. It is late evening at a remote airstrip carved from a highway. A pilot climbs back into the cockpit 20 minutes after landing. A small team finishes refueling while another loads air-to-air missiles beneath the wings. The jet takes off again before a traditional airbase could even prepare a hangar. That image illustrates the core difference between two design philosophies. One aircraft emphasizes cutting-edge technological dominance. The other emphasizes survivability through mobility and simplicity. Neither approach is automatically superior, but together they reveal the deeper tension shaping modern air forces. Because the future battlefield is changing faster than aircraft development cycles. The F-35 program began development in the 1990s. Today, the military world is already discussing sixth-generation fighters, autonomous drone swarms, and artificial intelligence targeting networks. By the time many countries finish purchasing their current fleets, the next technological shift may already be underway. And that leads directly to the next escalation in this story. The debate over fighter aircraft is no longer just about fighters. Because the moment drones entered the equation, the entire air power calculation shifted again. For decades, air superiority revolved around one central assumption. The most advanced fighter aircraft in the sky controlled the battlefield below it. That assumption drove billions of dollars in research, stealth coatings, radar technology, and advanced avionics. But military planners now face a different strategic landscape. Cheap unmanned systems are appearing faster than traditional fighter programs can adapt. Some drones cost a few $1,000,000. Others cost tens of thousands. A fifth-generation fighter costs tens of millions just to purchase and tens of thousands per hour to operate. And that difference forces a difficult question inside every defense ministry. If the future battlefield includes large numbers of autonomous or semi-autonomous systems, does it still make sense to concentrate so much capability inside a single aircraft platform? The answer is not simple. Fighters like the F-35 bring sensor fusion and stealth advantages that drones cannot replicate alone. But drones bring something else entirely: scale. Hundreds of smaller systems can overwhelm defenses through numbers alone, forcing traditional aircraft into new roles as command nodes rather than lone combat platforms. That shift is already underway. The United States Air Force has begun developing concepts like collaborative combat aircraft, which envision drones flying alongside piloted fighters as force multipliers. These unmanned systems could carry missiles, electronic warfare equipment, or additional sensors while the pilot remains the central decision-maker. Several other nations are exploring similar concepts. Europe's Future Combat Air System and Britain's Tempest program both imagine networks of aircraft and drones operating together as integrated systems. But that still leaves the current generation of fighters operating in a transitional moment. Because the aircraft being purchased today must remain effective for decades. The F-35 is expected to remain in service well into the middle of the century. The same applies to aircraft like the Gripen, Rafale, and Typhoon. Each country investing in these platforms must consider how they will integrate with technologies that may not fully exist yet. Future warfare planning, therefore, requires balancing immediate capability with long-term adaptability. And here the debate becomes even more politically sensitive. Defense procurement decisions carry enormous industrial consequences. Fighter aircraft programs support thousands of jobs across manufacturing plants, engineering firms, and technology suppliers. The F-35 program alone involves companies and subcontractors across multiple countries, creating an industrial ecosystem tied closely to the aircraft's success. When governments choose one fighter over another, they are not only selecting a military platform. They are selecting an industrial network that may last for decades. If you noticed those signals building before this conversation intensified, how long ago did you start watching it develop? Because analysts inside defense economics have tracked these procurement patterns for years. Large multinational programs like the F-35 create powerful incentives for participating nations to remain within the system once they join it. Training pipelines, maintenance facilities, and supply chains gradually intertwine across allied militaries. Over time, the network itself becomes a strategic asset. Interoperability allows pilots from different countries to train together, share data, and operate within common command structures. That advantage carries real strategic weight. NATO's strength has long depended on the ability of allied forces to integrate rapidly during crises. Shared aircraft platforms simplify logistics and communication. The more countries operating the same system, the easier it becomes to coordinate missions and share spare parts. From that perspective, the F-35 network acts almost like a technological alliance within the broader NATO structure. But that strength also introduces vulnerability. If dozens of allied air forces depend on the same aircraft platform, disruptions to that platform ripple across the alliance simultaneously. Software updates, supply chain bottlenecks, or maintenance challenges affect everyone at once. That does not make the aircraft ineffective. It simply concentrates operational risk within a single ecosystem. And this is where the early detail from the beginning of this story starts to matter again. Remember the engine inside the Swedish fighter. That component exists because modern aircraft manufacturing has become deeply globalized. Even systems designed for strategic independence rely on international supply chains. Engines from one country, avionics from another, software developed across multiple continents. The modern fighter jet is not just a machine. It is the product of an entire international industrial web. That web shapes geopolitical leverage. Countries controlling key technologies can influence how and where advanced systems spread. Export licensing rules determine which nations gain access to certain capabilities. Defense partnerships create both cooperation and dependency at the same time. In the case of the Gripen, the American engine places a U.S. decision point inside a European aircraft program. In the case of the F-35, the supply chain spreads across numerous allied nations who now share responsibility for the aircraft's long-term success. Picture this. You are inside a defense planning meeting late at night. Procurement charts cover the table. On one side sits the most technologically advanced fighter system ever deployed. On the other sits a more affordable aircraft built around flexibility and rapid deployment. Both aircraft come with decades of consequences. The budget cannot support every option simultaneously. And whatever decision you make today will shape the Air Force for 40 years. This is the strategic dilemma behind the headlines. Both cannot be true. Which explanation matches what you are seeing and why? That dilemma only becomes clearer when the numbers return to the center of the conversation. $1.8 trillion remains the anchor. That projected lifetime cost for the F-35 program sits behind every procurement decision, every readiness debate, and every political argument surrounding the aircraft. The number covers development, production, and decades of sustainment for a multinational fleet expected to serve until roughly the 2070s. Supporters argue the cost reflects unmatched capability, stealth, sensor fusion, and battlefield networking that no fourth-generation aircraft can fully replicate. Critics respond that the scale of that investment concentrates too much capability inside a single, expensive ecosystem. But that is only the surface layer of the strategic tension. Because the deeper question concerns resilience during long conflicts rather than isolated engagements. Modern wars increasingly involve prolonged campaigns, stretched logistics networks, and continuous drone surveillance across the battlefield. Aircraft that require specialized facilities and large maintenance teams may struggle if traditional bases become vulnerable targets. Military planners have studied this problem carefully in recent years. Distributed operations and rapid dispersal are now recurring themes across multiple defense doctrines. That design philosophy suddenly makes the Swedish highway image from earlier look less theoretical. During the Cold War, Sweden expected any conflict to begin with strikes against its airfields. The BAS-90 concept deliberately scattered aircraft across roadways and remote strips to prevent a single attack from grounding the entire fleet. Mechanics trained to refuel and rearm jets quickly using small mobile teams. Pilots learned to launch from improvised runways surrounded by forests and farmland. The system existed because centralized infrastructure can become a strategic weakness once war begins. And modern warfare increasingly targets infrastructure first. Missile technology has advanced dramatically in the last 2 decades. Precision weapons can now strike air bases hundreds or even thousands of kilometers away. Satellite reconnaissance allows adversaries to track aircraft movement with increasing accuracy. As those technologies spread globally, the survivability of traditional air bases becomes a serious strategic question. That reality explains why many defense planners now study distributed operations with renewed urgency. You are watching this calculation unfold in real time before most people have connected these dots. Because the real debate was never simply about the F-35 versus the Gripen. The deeper question concerns how air forces balance advanced technology with operational resilience. Stealth fighters offer capabilities no fourth-generation jet can match in certain environments. Yet lower-cost aircraft allow more pilots to train, more patrols to fly, and more jets to remain active during extended operations. Most analysts increasingly believe future forces will blend both approaches. That hybrid structure is already beginning to appear. The United States continues investing heavily in the F-35 while simultaneously developing autonomous drone partners through the Collaborative Combat Aircraft Program. European countries purchasing the F-35 are also funding sixth-generation fighter research programs that include swarming drones and distributed sensors. The direction of travel is clear. Future air power will likely consist of networks rather than individual aircraft dominating the sky alone. But that transition period carries its own risks. Every aircraft purchased today will remain in service long before those future systems arrive. Defense ministries must commit billions of dollars before the next generation of technology fully matures. Decisions made this decade will shape pilot training, industrial capacity, and alliance integration for the next 40 years. That is why procurement debates become so intense. Governments are not simply buying airplanes. They are choosing strategic pathways. And here the early detail planted at the beginning finally reveals its full weight. The American engine inside the Swedish fighter illustrates how intertwined global defense systems have become. Even aircraft designed for independence still rely on international components. Export approvals, technology sharing, and industrial partnerships quietly shape which systems nations can actually field. The network of alliances supporting modern defense programs has become as important as the machines themselves. That reality circles back to the number that opened this story: $1.8 trillion. Not just an aircraft program, a strategic ecosystem linking dozens of air forces, supply chains, and training networks across the Western Alliance. Supporters see that ecosystem as a powerful advantage built on shared technology and interoperability. Critics worry that concentrating so much capability inside a single structure could create vulnerabilities if problems emerge inside that system. The question is not resolved. Over the next 30 days, multiple defense reviews and readiness updates are scheduled across several NATO members operating advanced fighter fleets. Those reports will reveal how availability rates, maintenance costs, and pilot training hours are trending across different aircraft platforms. The results may not settle the debate, but they will offer another glimpse into how these competing philosophies are performing in practice. And the consequences will not stay inside military planning rooms. Air power determines how nations defend their airspace, protect allies, and project stability across volatile regions. The aircraft chosen today will influence those capabilities long after current political debates fade. For the next generation of pilots, these decisions will define the tools they carry into the sky. $1.8 trillion started this story. What happens if the future of air combat costs far less?